from a height of 25 meters above the ground. Find the time taken for the stone to reach the ground. So I typically like to write like this. So SUVAT, and then literally fill in the information that I have. So with this kind of question, it's a stone and it's being dropped downwards. Don't know why I put those lines around the stone, but that's my stone. And we know certain things. So we know, for example, what S is. We know it's going to be 25 in some way, shape, or form. And because it's dropped, it started from 0 and you let go of it. So we know its initial velocity is 0. And we also know what the acceleration is. We know the acceleration due to gravity is 9.8, as it is on Earth. One thing that we do need to decide is whether we want up to be positive or down to be positive. And you've always got to make that decision when you do a question. So I'll leave that for you to decide. What would you like?
So down would be positive and up would be negative.
Okay, so you want down to be positive and up to be negative. Okay. So the S, because it's 25 because it starts off 25 meters above the ground and it goes downwards, S is going to be positive, 25. U, well, is 0, so it doesn't really matter if it's positive or negative. A would be 9.8 positive because acceleration due to gravity always acts downwards.
Okay.
And so we've got the information for S, U, and A. Now it says find the time taken for the stone to reach the ground. So we're trying to work out T. So to decide which formula to use, we need to look at the formula that we have, or think about the formula that we have, and think which one has S, U, A, and T.
Okay.
So, for example, V equals U plus AT. Well, that one doesn't have S in it. And it's got, one of the things that we don't want. V squared equals U squared plus 2AS. Well, it doesn't have T in it, and it's got the V that we don't want. But there is the formula, S equals UT plus a half AT squared. And then we can just fill in what we know. So S is 25. That equals UT, so U is 0 times T, so 0T, plus a half times A times T squared. So we've got a half times 9.8, which is 4.9, so plus 4.9 T squared. So 25 equals 4.9 T squared. Then we have 25 over 4.9 equals T squared. And then we can solve this. T is equal to the square root of 25 over 4.9. You might wonder, but we normally take the positive and negative square root. Because time is a scalar quantity, it cannot be negative, so we just take the positive square root. And then that would be our answer for part 1.
Good.
And then thinking for part 2, we have that it says find the speed of the stone as it hits the ground. So using our same SUVAT information again, so S equals 25, U equals 0, V equals blah, 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 A equals 9.8. What I like to say is, as a rule of thumb, is unless you cannot do it, try not to use an answer from a previous part of the question. So here I could put my T value of the square root of 25 over 4.9, and it probably would give this the right answer because I'm confident that the part 1 is correct. However, it is possible to do it without using T, and I would always advise that just in case, on the off chance that you happen to just have made a slip without realizing, you don't want your error to carry forwards basically into your next question and affect that. So we have SUA, and we're trying to work out V this time. So we need a formula that uses SU, V, and A. And in this case, that's going to be V squared equals U squared plus 2AS. And it's because it says find the speed of the stone as it hits the ground. So V squared equals 0 squared plus 2 times 9.8 times 25. And then you've got V squared equals, yeah, that.
Okay.
So 2 times 9.8 times 25. And then V is the square root of that answer.
Got it.
Should probably actually calculate this with a calculator. So I'll do that. So our T value is going to be square root of 25 over 4.9. That is 2.26 to 2 decimal places.
Okay.
And then our V value is going to be 22.14 to 2 decimal places. Okay. Okay, cool. So, yeah. Then we've got a large package is dropped from the same height as the stone. Explain briefly why the time taken for the package to reach the ground is likely to be different from that for the stone. Well, with this kind of question, gosh, it's 2 marks as well. Okay. Well, normally what we'd want to say is that acceleration due to gravity is going to be the same for all objects, which is true. However, in real life, we normally include the notion of air resistance. So part of our question is going to be like something to do with air resistance. So account for air resistance. But that's one part of it. Another part is the stone and package are different sizes, so have different surface areas. So small stone and large package have different surface areas, so will experience different air resistances. Again, I've not tried to phrase this in like a scholarly manner, so to say, but I think it gets the job done. So we account for air resistance, and because the small stone and the large package have different surface areas, they're going to experience different air resistances. Yeah, so therefore their accelerations will be different. Basically. So accelerations will differ.
Wait, acceleration or speed?
Well, the accelerations will differ because if I don't know if you know about F equals ma.
Yeah.
So F being resultant force, you've got the weights of the objects, and you've got the resultant force, and that determines the acceleration. But then that will then change the speeds.
Got it.
So if it happens, they may reach terminal velocities at different points. But even if that doesn't happen, the accelerations will have to be different. So that will also, in fact, affect their speeds. Because if two objects start at 0 meters per second and they have different accelerations, by default, they're going to have different speeds. Because if they both start at the same speed and have different acceleration is what causes you to get from one speed to another, right? So if they both start with 0 and they have different accelerations, then they're going to end up having different speeds.
Got it.
So then they will hit the ground at different times. Yeah.
Okay, got it.